Hi everyone, welcome to Math Wizards 123. In this live stream, we're going to take a look at how to use the PEMDAS strategy to solve problems that have fractions with more than one operation. So welcome into the live stream. And this time, actually, this is the live stream where everybody who is in with me is going to have their name entered into the raffle for the Starbucks gift card. So that would be announced next Wednesday. Hello, oh, here comes everybody. Hello, Jaden's here. Hi, Neil. Oh, Neil's here. Awesome. We have a 7th grader with us, guys. Okay, I'm going to just set the hat over here, and then if you want to grab a pencil and some paper, this is the first problem we're going to take a look at together. Hi, Jaden. Hey, Drake's here. Awesome. And who else? Oh, Lexi. Hi, Lexi. Okay, so once you're ready, let's take a look and see how it works when we have fractions in here with a problem that has more than one operation. So I can see we have division and we have subtraction. So we're going to use our PEMDAS rules over here to figure out what to do first. So looking here, I don't see any parentheses, so I can cross this out. And I don't see any exponents anywhere, so we're going to jump right to multiplication and division. So, hi Andrea. How are you? I'm glad you could make it. Good job. Yeah, we're going to do division. So I like to go ahead and wrap a rectangle around. I find the symbol, so from left to right, this is the only multiplication and division symbol. So we're going to use the values that are right around that symbol and then solve that first. Okay, so let me grab this. Does anybody know what I should do with the whole number if I'm going to get ready to set this up? Because I know I'm going to take this and turn it into an improper fraction. But what should we do with the whole number 9 if I'm going to get ready to divide it by a fraction? What should I put under the 9? So I'm trying to think about what the denominator might be. Convert to 9 out of 1, or 9 over 1. Good job. Okay, thanks, Drake. I'm going to use your idea here and just set this up. So 9 over 1, and this is divided by 8. Well, let's go ahead with this and convert it. So instead of just copying that down here, I can save a step. And let's turn this into an improper fraction so it's all set up and ready to go. Is Dario here? Oh, is that Dario? Hi, Dario. Okay, so looking at 8 and 1/10, how does that convert to an improper fraction? I see 81 over 10 and 91 over 10. I see 81. Hi, Solomon. Awesome, I'm glad you could be here. We are right in the middle of solving this. So we're taking a look at the first step, how to divide 9 divided by 8 and 1/10. And we're trying to convert this into an improper fraction. Okay. Drake thinks now it's 81, and I see 3 more 81s over 10, so I'm going to go with that. So 8 times 10 is 80 plus 1 more. That makes sense. So I'm solving this right now. We're going to take care of this part later. So just moving along, I know that if I have a division problem that involves fractions, there's something that I can do with that to make it a lot easier to solve it. Does anybody remember what I can do with this division symbol to make this easier to solve? Hi, Jesus. We have another 7th grader. Awesome. Welcome. If you have a pencil or if you want to just watch and give us suggestions, that's great too. You've solved these a lot last year. What do we do with division when we're using fractions? Should I leave it like this? Or is there something else I can do? Multiply, change denominator with the new, okay, so we're going to convert it to, and I think that came from Drake, we're going to convert this into a multiplication problem. So when we do this, we say keep it, change it, and then what? Keep it, change it. What else? Does anybody remember the rule? Keep it, change it. There you go. Good job, Jaden. Keep it, change it, flip it. So I'm going to keep the first fraction, change the operation to the opposite, which is multiply, and then we're going to flip it. So now the 10 will go on top as the numerator, and the 81 will come down here on the bottom. Awesome. Good job, Lexi. So now I'm going to change colors real quick. If you look at the pairs, the numerator and the denominator going across from each other, let's try to reduce these so that way it'll be easier when it's time to multiply going across. So how can I reduce the 9 and the 81? If you need to, you could put this in the ladder like this and then figure out how can we reduce those numbers. Okay, 9 converts to a 1, 81 converts to a 9. So I'm going to cross this out here, and that makes sense. Now if you're using the ladder, you can look at both numbers and decide, you know, what can they both be divided by. So 9 times 1 and 9 times 9 makes the 81. So then 1 and done. The 9 does convert to a 1, and the 81 does convert to a 9. So that makes it easier. And then the 1 and the 10, we can leave those as they are and then just get ready to go ahead and multiply across. So now we have, instead of a 9, we have 1 times the 10. And then we have a 1 times the 9 down here on the bottom. So what do we wind up with now? Good job, Jaden. Yeah, we changed the 81 into a 9 here. So what is our answer to this come to at the very end, guys? When you do the multiplication going across the top and then across the bottom with your denominators. Just remember to grab the 1 here instead of the 9 and multiply by the 10. So Drake is thinking 10 over 9, 10 over 9 again. I'm going to set this here and see if you guys agree with that. 10 nights. DJ, good night. Does that mean you're leaving? Or are you saying good evening? Are you saying, maybe you're saying goodnight to somebody else in the stream. Hi DJ, it's good to see you. Remember, this value right here is equal to this. So we just solved this portion right here. So now what I'm going to do is I'm going to replace this right here with 10 ninths, and then we're going to finish solving this problem. So we have 10 ninths. Still, we need to subtract 5 ninths. So I want you to take a look at this as it is and see, sometimes we can take addition and subtraction of fractions and put it in the butterfly if we want, or we can search for common denominators. But when you look at this one, does it already have common denominators? 10 ninths minus 5 ninths. All right, that makes sense. To go ahead and just subtract them, and then I see that Lexi already came up with her answer. So because the denominators are the same, we don't need to use the butterfly strategy right now. We can just go ahead and do the subtraction. So 10 minus 5 is 5, and then these are ninths. So that stays the same. Okay, great job, guys. So the final answer to this one is 5 ninths altogether. Okay, so we're all finished with this because we already solved this part right here. Let me just cross these out. We did the division, and then we took care of the subtraction. So this value, which was 10 ninths, subtracting the 5 ninths, we took care of that. So we are all finished. Okay, so now I'm going to switch to the second problem. You still have room on your paper. Let's see here. Get ready for this one. I'm going to go ahead and just set up my letters over here again, just to remind myself what the order of the operations should be, so I'll know what to do first and what to do next. And so we have 4 and 7/12 divided by 3/4 and then multiplied by 3/11. So what do you think I should do first? Looking at this, let me just grab my, let's see. There's no parentheses, so I'm going to just cross these out, and there's still no exponents here. We're jumping right to multiplication and division again. So what do you think? Divide? Divide first? Okay, that sounds good. I'm going to go ahead though, when I move from left to right, I'm just looking for, you know, which one is going to come first from left to right. So I just kind of track it. This is the first symbol we see, so that makes sense that we're going to divide these two values first. But I like to separate it out just with a rectangle so it makes it easier to see what is left at the end that we need to take care of. Okay, good job, Jesus. So now in order to get ready to divide it, let's take care of this. This is a little bit larger number, but we will reduce it and make it simple. But how can I convert the 4 7/12 into an improper fraction that'll make it easier? Some students like to draw the arrows around it, so you can do this if it helps you. Remember the steps. We multiply first, and then add the 7 extras more, and then what do you come to? 55/12. I see that once, twice. If you guys agree with that, that makes sense to me, because 48 plus 7 more is 55, and the denominator stays the same. Okay, so then this is division, so I'm just going to copy it as it is right now, and then I'll take a look and set it up in a simpler way. So since this is dividing fractions, we know we can make this a little easier by converting it. Okay, good. Thank you, Drake. You agree with that? So now I'm just going to say that little chant to myself when I see division of fractions. I say to myself, I want to flip something, I want to convert it, I want to turn it into the opposite operation, so I'm going to keep it, change it, flip it. Good job, Lexi. So I'm going to keep this one here, 55/12. I'm going to change this right here to the opposite operation, and then we'll flip this, so that way we'll have the reciprocal. So the denominator of 4 goes on the top now, and then the numerator of 3 goes on the bottom. You guys are doing a great job. So looking at this, before I multiply, if I multiply this now, I'll get pretty large numbers. So I want to look and see if there's any way that I can reduce this. So do you see any pair of numbers, a numerator with an opposite denominator, that we could reduce? 12 and 4. Okay, I'll connect these here, and then maybe you can take a look at that. If you need to put it in the ladder to reduce it, you can set it up like this and think of a number that they can both be divided by. Do that division, and then see what comes. So this is now down to a 1 and a 3. I see it there. 4 and 12. Oh, that's okay, Drake. 3 and 12, 4 and 12. Yeah, we're going across, so we're always I always think of it like an X. I look at the opposite pairs. You can actually just draw it like that when you first are looking at it, and then connect them together. So since the 4 reduces to a 1, I can reduce this here. I like to just circle it so that way my eyes can see what the number is that I need to use at the end. And then the 12 converted to a 3. So I'm going to cross this out, turn it into a 3. And then what do you think about the 55 and a 3? Should we change those, reduce those, or leave it alone? Yeah, good job, Jaden. 4 converts to 1, 12 converts to 3. Oh, I see what you're saying, Jay. Let me look at what Jaden is saying. A 3 and a 12 converts to a 1 and a 4. What I'm doing is I'm going the opposite. I'm doing the opposites. So that's why I use this X in the middle to connect the opposite. So I want to do the numerator here with the denominator over here and just see if there's any way I can bring it down. Okay? So I think we're ready to move across. 55 times 1 is 55. And then 3 times the 3 over here makes 9. But then when I look at that answer, Is that going to be my final answer? Or is there anything else that I can do with that? 55 out of 9. Good job. That's what I have here. Should I leave it like this, where the value is larger on top than what the value on the bottom is? Okay, thank you, Drake. This is an improper, so we always want to check first to see, is it improper? And then after that we can see, is there anything else left to simplify? There shouldn't be on this right here because we already simplified it when we did the cross canceling, but we definitely can take this and put it in the doghouse. So I'm going to give you guys a minute to see if you can finish solving this one. You can move down anywhere you have space on your paper and put your numerator in the doghouse, divide by 9, and then we're just simplifying the answer. Okay, I have a 6 1/9 so far. That makes sense to me because 6 times 9 I know is 54. And then when I subtract, there's 1 left over. I'm going to circle this to separate it here. And these are still ninths, and there's 1 left over. So if I put that up top, that brings me to a final answer of 6 1/9. That was a lot of work on that one. So we just have a lot of steps to remember, but you guys did a really good job on these two. So great work. And be sure to tune in next Wednesday, okay? All of your names in here. If you haven't typed in your first name, be sure to do that. So that way I'll see it next to your Gmail account and I'll know who's who. But I'm going to put all your names in this hat, so tune in next Wednesday at, I'll be announcing it at 4 o'clock, but if you're out trick-or-treating or doing Halloween things at that point, don't worry because I'll post a video and then you can check in just to see who the winner is. Okay? I'm just checking to see what Lexi's saying here. 3 over 11. I'm looking to see. I don't see. Yeah, no, Jesus, we didn't need to do the butterfly form on this one. We use the butterfly method when we are adding or subtracting fractions. Oh, look it. Look what I forgot to do. You're right. 6. Oh no. Lexi's trying to tell me right here that we forgot about the rest of the other stuff. Oh my goodness. I was ready to sign off. Okay, I must be tired, guys. Let me grab. It's 55 ninths. Hello. We have to finish the PEMDAS. We still have this right here. Okay, thanks for waking me up there. Maybe I'm going to give you double raffle tickets for saying something. Okay, let me come back to 55 ninths. I'm going to pull this on the next sheet here. 55 ninths, guys. If we didn't have this, this would have been the answer, but we still have this part right here. So we need to pull this over. 3 over 11. I just kept looking at it, Lexi, going, 3 11ths? Where did that come from? Oh, yeah. Alright, guys, let's grab this and see if there's a way to reduce these. So I'm going to go like this and just make an X right away. Okay. Drake, where'd you get that emoji? That's hilarious. I haven't seen that one yet. Okay, so let's see. 3 and 9. How can I reduce the 3 and the 9? I'm going to just cross them out right now because I know you guys can reduce this. Hi, Caesar. Okay, good. So the 5 and 55 and the 11 reduces to a 5 and a 1. So I'll do that for you guys real quick. There's that. 3 and 9 equals 1 and 3. Okay, so here's a 1 and here's a 3. Then what? Are we ready to multiply across yet? Okay, Drake got 5 over 3. Lexi has a 5 over 3. Okay, great job, guys. Yes, it is improper. So now we can do putting it in the doghouse and then see what your final answer is here. Now that we've actually solved the whole problem and not half of it. Okay. This is a pretty easy one to divide. I bet most of you can do this in your head. Yeah, 1 times 3, right? And then you get 2 left over. So if I just pop this here, I always pull my leftovers up on the top. So there we go with the final answer. Great job, guys. Lexi, you're going to get double raffle ticket for that one. So make sure you tune in next Wednesday, and then we'll see whose name we pull out of the hat. Awesome work. And thanks to all the 7th graders that came in the room with us. That's really awesome. You're helping us solve problems together, you guys. Okay, so go ahead and just wave out. Send a quick emoji to your friends before I click us out here. And I hope that helped you with your homework. Now that we finally got the right answer on the second one. Okay, bye guys. Give a quick wave to your friends before I hit the button, if you like. Bye, Lexi. Have a good night. We'll see you guys tomorrow. Bye. I gotta find out where that cool emoji is. Okay, bye, Chris. Thanks for helping us. We'll see you guys next week. I hope you're a winner. I might pull two names out of the hat, by the way. So let's make sure you tune in. Okay, bye, guys.